Command put that there is a visual aid designed to help military leaders better communicate their plans to their subordinates. It uses two modalities, speech and hand tracking. It can be seen as the virtualized version of the terrain model kit, the current best solution. Here's a demo of the system. This is Operation Big Dog. First squad is here. Enemy squad is here. Objective Beaver is here. Time is now 0800. This is phase 1. The objective rally point is here. After 30 minutes, first squad will move 90 degrees for 250 meters to here. In phase 2 at 0930, second squad will lay suppressing fire on the enemy. Then this squad will attack that squad. First squad will assault through to here. At the same time, first squad will then carry on to secure objective Beaver. Play from phase 1. Speech is parsed through the web speech API, while hand tracking is done with the leap motion. Both inputs are then used to figure out which command the user wants. The leap motion component was very simple, used mostly just to designate a location on the board. The user can also scroll through the instructions or script by making a fist, so that the entire interface is usable without a mouse or keyboard. The other modality, speech, is much more complex. The original plan was to interpret natural speech, for it to sit in the back and react to communication between leaders and their soldiers. I ended up having to pivot away from natural speech, but what's important is that this system was built with flexibility in mind. In that spirit, I used a keyword searching approach for speech processing. Here's an example in parsing a move command. It first detects the action via the keyword move or going. From there, it looks for the source, which is caught via the keyword platoon. It takes the word prior to that, the word first in first platoon. For finding the target, it works very similarly, except that in this case, with the move, it'll also detect places like objective Beaver or the word here, which will then look at where the user's hand is from the leap motion. Finally, you can reference things by combining both modalities with the word this and that, which can reference two different things designated by the user's hand. For user testing, cadets from Army ROTC were given a pre-planned mission very similar to the demo, but without an exact script. Instead, they just spoke naturally to the system. If it didn't work after 2 or 3 tries, I would come in and give an example command. But this turned out to be almost always an interesting failure because basically for 5 different subjects, I had 5 very different ways to direct the same command. For everyday speech, this makes sense, but even in a highly constrained and specific domain, there were huge variations in not just vocabulary, but also structure and syntax. However, a very interesting observation came up during testing. All users got the last tactic on the first try. They were quickly picking up the structure and syntax just from me giving an example command. So while my system wasn't natural, it showed promise in learnability. With that, I decided to pivot my project away from natural speech and instead to a set of commands requiring active interaction. Many difficulties arose with speech recognition. There were some misinterpretations not just from the system hearing wrong, but also from the web speech library itself on consistency. The solution that was simplest was to just replace common misinterpretations with the correct ones. The system has a highly restricted domain and there weren't that many, so just patching them up individually worked very well. One valuable lesson from this project is that natural speech is really hard. Keyword searching proved not enough even for a very specific use case, so my opinion is that interpreting natural speech requires a much more robust speech understanding system grounded off of semantics and context instead of whether or not the user said a certain word. But my biggest lesson has less to do with modalities and more with working on projects in general, in that I definitely spent too much time future-proofing the backend before I even had the MVP. During the prototype studio, I actually had 90-95% of the backend done, but my speech component could only make use of about 40% of that. Things turned out okay, but I should have adhered closer to my projected milestones. Regarding next steps for the project, the simplest is to just expand on more unit types and tactics. For hand tracking, it could be expanded to draw the path of movement for a command like "we will hug along this road." For speech, more can be done, but overall I'm fairly happy with its performance right now, and I believe the next step would be to go back towards natural speech, which means revamping it to work off of context and semantics instead of just keywords. Finally, an important component of each plan is where the leader, him or herself, is located, designated with a leader piece. This would definitely expand on speech capabilities. When the user says the pronoun re, that would refer to all the pieces currently attached to that leader piece. That wraps it up for this presentation. Thanks for listening.